Hello everyone. The previous video, we discussed some of the networking terminologies. In this video, we'll look at a couple of WAN technologies and in that process, also look at what software-defined networking is. Let us get started. Let us first look at what exactly is a WAN. We had discussed how a network inside an office can be called as a local area network or LAN. Our analogy here has a LAN kind of scenario where two office buildings are connected using a road inside their premises. Let us say the company has another facility on the other side of the city. And the company has to connect to their other campus. They have two possibilities. Either take a dedicated bridge they have between the two offices or use a shared public road which has a lot of other traffic. This is exactly how the offices are connected using wide area network or WAN. And the branch offices, which are local area networks, have to be connected to other branches or data centers or campuses. They either use a dedicated link, mostly utilizing a service provider network, like shown with the blue line here, or they can make use of the internet to connect between the offices, like using a VPN, for example. Let us now look at some of the major WAN technologies prevalent today. Multi-protocol label switching, or MPLS, is one of them. MPLS uses label switching at its core. To understand label switching, let us get back to the postal system we had discussed in one of our previous videos. While distributing the letters in a locality can be done based on the address written on the envelope, a letter being sent out to another part of the country or state is difficult to be identified by a local post office based on the address. So what do they use then? You guessed it right. It is a zip code that is used for this purpose. The zip code is used as a label to identify the regional or the city post office where the letter should actually go to. Once the letter reaches the city post office, it is now the address that is used to deliver the letter. In our example here, the two letters have different zip codes, and it is based on this zip code that they'll be forwarded to the destination city. On the way, they will pass many sorting stations across the country or state, and based on the same zip code, they'll be sorted and sent to the right destinations. In MPLS, the same concept of label switching is used. When a data packet, or IP packet as we call it, reaches a router supporting MPLS, the router appends a label to the packet, just like the zip code we discussed in our analogy. Once the traffic has reached the end of label path, the IP address is used to make the final delivery to the end user. In the network represented here, we have two organizations, Org A and Org B. When Org A sends some information to its branch office on the other side of the country, it enters an MPLS network provided by a service provider. And when it enters a service provider network, a label is attached to it. As an example, let's say it has been assigned a green label. The data packet passes through the MPLS network using this green label and reaches the destination of Org A. The routers in the middle use the same green label to forward the traffic to its destination. Similarly, the Org B requests will reach the Org B destination based on the orange label. Since the destination is identified using labels, the routers do not have to look at the destination IPs anymore. It just switches the packet to the next router, and the data sent from Org A will always reach the branch office of Org A on the other side of the network, and similarly for Org B. MPLS is quite an old technology, but is still very much alive due to its scale, security, and faster switching. The label switching technology we just discussed reduces time and overhead and plays a critical role in remote branch connectivity and in today's internet. Software-defined networking. Let's take a city with busy roads and assume each road has some traffic lights, road signs, and there are laws which govern how people and vehicles should move around. When an ambulance approaches a traffic signal, maybe the particular traffic signal can handle the traffic to allow the ambulance to pass. But another traffic signal in the city will adjust the traffic only when it realizes that an ambulance is in the vicinity. This will cause a delay to the ambulance handling an emergency. Imagine if a centralized traffic controller was in place. This could have been handled in a much better way. The centralized controller will have a total view of the city, and if it finds the ambulance leaving towards the hospital, the controller can make sure that the traffic signals along the way is handled such that the ambulance reaches the hospital on time. This is possible when we have a centralized traffic controller, which is handling all the traffic and traffic signals in the city. In a traditional network, a switch or a router acts like the individual traffic signals in the city. It has a built-in brain, but decides what to do with the information it receives. But it does not know what else is going on in the network. It acts based on the information configured in it. With SDN, the brain of the network becomes centralized as shown in the diagram here. It has a total view of the network and can take decisions keeping the overall network in mind. The control of the network is now with the SDN controller, and the data, which is like our ambulance in the analogy, just needs to pass through the devices. The controller can also talk to the applications directly. Let's say two gamers are busy playing a strategy game. The game application can talk to the controller, and based on the interaction, the controller can provide best network performance to the gamers, like maybe providing each a better QoS over the network for the gaming application. To sum up, SDN is a smart system that centralizes resource management in a network so that administrators can manage traffic responsibly and efficiently. This brings us to the next WAN technology called SD-WAN or software-defined WAN. It has been gaining a lot of popularity among the service providers and enterprises. SD-WAN works on the fundamentals of software-defined networking. It is how SDN works in a WAN scenario. Let us understand this with an analogy. In the picture here, we bring back the traffic controller from the SDN slide. Here, the job of a traffic controller is to monitor the traffic coming from the outskirts of the town. Let us say we have traffic coming from this remote location to the city, including cars, buses, even ambulance coming from a remote hospital to a main hospital in the city. There are two means of reaching the city. They could either take the flyover or take a road which comes passing through the heavy city traffic. The traffic controller can regulate the traffic between the flyover and the city road and decide which vehicles should take which road. This is exactly how SD-WAN works. The organizations now have the facility to get the best of internet and the MPLS worlds. And when I say internet, it could be broadband, 4G LTE, or even the upcoming 5G. The decision to switch the traffic between these links can be taken by a centralized SD-WAN controller. This helps the organizations to drive down the cost as now they can route some of the traffic via the inexpensive internet. It also provides direct internet access to the branch offices without having to go all the way to the data centers for the internet connectivity. To sum up, branch to branch connectivity, branch to campus and data center can be done using SD-WAN, utilizing the services of MPLS and internet, thus providing the best of both worlds. Let us take a look at what we have discussed so far. We saw how WANs connect different remote locations. We also saw some of the WAN technologies, starting with MPLS. We saw how it uses labels to transfer the data between the different locations like branch, campus, and data center. Then we looked at SDN and how a centralized controller gets a better view of the network and helps to take decisions in a fast and efficient manner. And finally, SD-WAN, which uses the same concepts of SDN and tries to provide remote branch connectivity using MPLS and internet technologies. Thanks for watching.